Hi, everyone. Today, my group and I are excited to present to you a topic that connects principles we learned in Chem 110 to real-life application, the chemistry behind pregnancy tests. My name is Yash Gill. In this group, we have Carolina Ingenito, Kate Rourke, and Fernando Robles. So just a real quick overview of the significance and the types that we're going to be talking about today. Significance, it's pretty self-explanatory. Pregnancy tests are widely used to determine pregnancy, plays a vital role in our society. And the two types we're going to be talking about today are urine-based pregnancy tests and blood-based pregnancy tests. So the HCG specifically, so HCG is human chorionic gonadotropin, probably the most vital part of understanding pregnancy tests. So I'm going to explain it just real quick before we go into the more chemistry aspect of it. During pregnancy, the developing placenta produces HCG. This hormone serves several important functions in supporting the pregnancy. One of its primary roles is to maintain the corpus luteum, a structure in the ovary that produces progesterone. Progesterone is critical for maintaining pregnancy in its early stages. The detection of HCG forms the basis of pregnancy tests. These tests are designed to identify the presence of HCG in a woman's body, which indicates that fertilization and implantation have occurred. By detecting HCG, pregnancy tests provide a reliable and accessible method for women to confirm their pregnancy status. The structure of HCG specifically is C55, H75, and 17O13, as seen on the right. And then HCG is primarily composed of proteins, which are large biomolecules made up of amino acids, like we learned in class. The amino acid sequence determines unique properties and functions of proteins. HCG is classified as a glycoprotein, which because it contains both protein and carbohydrate components. The amino acid sequence and glycylation patterns contribute to the detection of HCG in pregnancy tests. Understanding the protein structure and composition of HCG is important for developing accurate tests and looking at its role in reproductive health.
So pregnancy tests are immunoside tests, which revolve around the reaction of a specified antigen and an antibody. And antibodies bind to antigens through non-covalent bonds, and each antibody is specific to a single antigen due to their own unique chemical structures. So HCG is released from the body through urine, and urine test strips contain antibodies with enzymes that are attached to them. And when urine containing HCG passes through the strip, the antibodies react with the HCG, and the attached enzymes cause dye molecules on the strip to change color, creating the stripe. And there are more antibodies on the strip that bind to extra HCG antibodies that create the control line. Okay.
And then the blood pregnancy test option is a quantitative blood test that measures the precise amount of HCG in your blood. So we can find even tiny amounts of HCG, making it very accurate. This way, women can know if they are pregnant before they miss their period. And the test procedure for this involves first collecting a blood sample, and then to isolate the HCG hormone, the plasma needs to be separated from the rest of the blood components. And then the chemical reaction takes place to detect the presence of HCG. As previously mentioned, the most common method of doing this is immunoassay, and immunoassay uses antibodies that specifically bind to HCG molecules. These antibodies are often labeled with a chemical or enzyme that produce a detectable signal. Next, there is the antibody-antigen binding, where the HCG molecules in the plasma bind to the antibodies present in the test kit, forming an antigen-antibody complex. These antibodies are designed to specifically bind HCG, guaranteeing its accuracy. Then there's the signal generation and detection. Depending on the type of test, the antigen-antibody complex can produce a detectable signal. As we experienced throughout the quarter with various labs, we can see a chemical reaction occur through various methods, such as color change, fluorescence, or chemiluminescence. Lastly, the test results are interpreted based on the presence or absence of the detectable signal, and the signal indicates whether HCG is present in the blood, indicating pregnancy. The concentration of HCG can also be determined, providing information about the stage of pregnancy. I hope this better helped your understanding of how chemistry is related to pregnancy tests. We certainly learned a lot in this course, and connecting the material to something many of us will use in our everyday life was very beneficial. Next time you take a pregnancy test, remember it's really a chemistry set. And here are our sources, and thank you for your time.